Welcome to AP Video 3.7, looking at making chemical equations. Main objectives: write a chemical equation in words, write chemical equation using chemical formulas, and then also be able to use the right states of matter symbols as part of the chemical equations. To focus yourself, make sure to turn off your cell phones and social media. Pause, rewind as needed, and write some questions or comments in the margins of your notes, and tomorrow we'll go over those. Here we go. So, chemical equations. The purpose of writing a chemical equation is to qualitatively and quantitatively describe a reaction. When we talk about qualitatively describing a reaction, we want to know which chemicals are reacting and what's the state of matter of those chemicals reacting. Quantitatively, we'd like to know what's the reacting ratio. So for example, if H2 plus O2 reacts to make H2O, okay, we want to know what substances are reacting. We want to know what their states of matter are if we can do that. So these are gases. And in this we end up with liquid water. And in addition, we'll get to the next video, we'll balance the equations. We want to know what the reacting ratios are. 2 hydrogen molecules react with 1 oxygen molecule to produce 2 water molecules. And balancing also shows a law of conservation of mass. So we're going to start off with just writing out word equations. Word equations are pretty straightforward. What you need to do is analyze the reaction description carefully, determine which are the reactants, and which are the products. And the reactants will be written on the left-hand side of the arrow, and the products will be written on the right-hand side of the arrow. So here it says when nickel 2 chloride hexahydrate is heated, it decomposes to form it's anhydrous form, which means without water, and water vapor. So to write a word equation for this, we'd write out like this: nickel 2 chloride hexahydrate arrow. It turns into anhydrous form, which means without water now, so it's still is nickel 2 chloride. And it also produces water vapor, and we'll just write down water like so. So this right here is the word equation. Just like that. Okay? Notice how there's no states of matter, there's no chemical formulas, it's pretty straightforward. We can add one more thing, which would be the word heat. If heat is required for a reaction to take place, you can write that above the arrow like this. You can also put a delta sign, which means energy is being incorporated to make this reaction happen. So sometimes we'll write stuff like that above there. Now, to a chemical equation, you want to turn all those chemical names now into formulas and symbols. So we're applied to the previous problem there. So in your notes you can kind of see a little better, but nickel 2 chloride hexahydrate is NiCl2 dot hexahydrate is 6H2O. And we're going to heat it up. And when you heat it up, it's going to drive off these waters, and we'll end up with the anhydrous form, just nickel Cl2 and H2Os, like so. And right now we're not really worrying too much about balancing, but you put a 6 right here. So basically it would drive off those 6 waters, it would separate them from the nickel 2 chloride. And then to add states of matter, it wouldn't be a bad idea here. So hydrates are solid compounds with the water attached to them, bound in the crystal itself. And you heat it up, we're left with the anhydrous form, which is still solid. And then when we heat it up, these waters are driven off, so they're actually going to be in the gaseous phase there. So we can add those states of matter there. We will focus throughout the next few weeks here, just kind of talking about what are the states of matter of common substances like ionic compounds, and what are your solids, what are your liquids, what are your gases. Alright, so that's kind of writing equations out. Here's a practice problem I'd like you to do. Go ahead and write your word equation, and then when you're done, write a detailed chemical equation. And I'll have you write these into Edpuzzle so I can check your answers. So you'll enter in separately a word equation and then your chemical equation. Don't worry about your subscripts. So if you have something like CO2, you can just write as CO and then 2 on your answer. I'll know what it means that the 2 is supposed to be a subscript. And please don't worry about balancing. Alright, enter those answers in, and when you're done, you can see how the answers are worked out. Okay, so in this question we have complete combustion of a complete combustion reaction where carbon dioxide, water, and heat are produced, so they're products. And it's the combustion of gaseous propane. So propane, you might not remember what propane is, but propane is C3H8. So word equation though, we have propane, and things combust in the presence of oxygen. That has to be one of the reactants with it. And our products again are carbon dioxide, water, and we can also throw in the word heat here as well. It's not going to be part of a balanced equation per se, but you can throw heat in. So this would be the word equation. And now the chemical equation, without balancing, turn these things into their chemical formula. So propane, you may not have known that one. Propane is C3H8. Oxygen is O2. Carbon dioxide is CO2. And water is H2O. And we can still write the word heat here. Propane is a gas. Oxygen is a gas. Carbon dioxide is a gas. And because we're doing combustion, heat's being produced, this water is going to come out as a gas as well. So that would be your chemical equation without balancing it right there. Alright, good job.